Hi, my name is Aaron Oates, and I'm a grade 7 student at St. Paul's Junior High in St. John's, Newfoundland. And I'm going to present to you my science fair project. So, my science fair project, I built a pair of Savonius rotor wind turbines with the help of my father, who is the man who's holding the camera. And I monitored them to see which one would generate more power, which one would generate more joules.
Okay, so tell me about these two turbines. Look pretty much the same to me. Can you tell me what's different about them? And
the difference is that with design A, as you can see, I'll turn towards the camera so you can see, all the sets of blades are parallel.
Okay.
But with design, well, this is called design A. With design B over here, as you can see, they're all angled differently. They're all offset.
Okay. And can you tell me what your hypothesis is then? Which one is going to possibly work better, give you more power and more energy, and why?
My hypothesis is that design B will generate more power, will generate more joules, because since the blades are offset, no matter what direction the wind is coming from, it's more likely to catch it and to harness it, and to turn the energy from the wind into electricity.
Okay, great. I can see a lot of electronics there and things hooked up. Do you want to explain what everything does? I see some flashlights and stuff and how that stuff works.
Okay, so I'll start with the flashlights. The flashlights, what they do is they take the energy generated from the wind, and it's used for something useful.
Right. Okay. Yeah.
Yeah. So it takes the energy from the wind and turns it into something useful, which in this case would be light for the flashlight.
Okay, and how does it do that? What's that little wheel down there?
The little wheel is the generator. That's where all of the power comes from.
Okay.
The wind comes through the blades, spins it, and this little wheel turns, and that generates electricity, which goes into the flashlight.
Okay, and you've got the same setup on both sides, right?
Yes.
Okay. And what does this thing in the middle do? Just explain that to us.
This is called an Arduino LCD display. As I turn it on here, I'm going to press this button and it turns on. And it shows us the exact amount of time, the total joules, which is a unit of energy, and the current voltage since it has been turned on.
Okay, so it's displaying 0 now on the voltage, and that's because it's not turning, right?
Correct.
So just maybe give us a whirl there.
I'll give design B a quick spin, and you see it goes up.
Okay, and then it drops back down, but the total count on the left there goes up.
Yes.
And just show me design A and see if it does the same thing.
It does the same thing.
Okay, great. So, have you encountered any problems since you ran the experiment?
Yes, we have encountered some problems. One day, the last test we had, the wind was so strong that that parts of each blade flew all over the place. So we had to use PL Premium to glue them back together and make them work again.
Okay, and so tell me about your results so far. Have you made any have you got any data to support? What does your data say? Is it bring me to any conclusion or?
Yes, the data so far. I'm going to take a few more tests just to be sure. But so far, it seems that design B is much more efficient than design A. Design B usually generates at least 100 joules.
Okay, so you usually get more energy. It turns better in low wind and medium wind and high wind.
Yes, no matter what the amount of wind that's coming, B seems to be always more efficient than A.
Okay, and what about design A? Does that turn in all types of wind too, or do you need a special kind of wind? Or
with A, you do need a lot more of a really big gust to start moving. Because say it's coming from this way, but you need to be coming from this way in order to get it turning.
So it's more difficult to start.
It is a lot more difficult to start. Yes.
Okay, well that's great. Thanks very much for the description. That's a good job.
Not a problem.